Okay, this is a solution for question 5 on the graphs transformation homework. It's an OCR question. I think it's from June 2005. It's a really nice question. We've got the function f divided by f of x is root mx plus 7 minus 4. And first of all, we need to give a sequence of transformations that maps the curve y equals root x onto this curve. And so we actually have 3 transformations going on here. We're multiplying x by m, so we've got a stretch in the x direction. The plus 7 here is giving us a translation in the x direction, and the minus 4 is giving us a translation in the y direction. Now, if we're doing translations in x and y, then it doesn't matter which order in particular we do those two in. So here, with the plus 7 and the minus 4, I could do this as 2 separate transformations, but it makes sense to do it in one go. I can actually do a translation of vector minus 7 minus 4. And that will get me the plus 7 and the plus 4. So that's what I've done first down here. I've applied a translation of minus 7 minus 4. I've shown my working out here by doing replacements. So to translate by minus 4 in the y direction, replace y by y plus 4. And then to translate in the x direction, replace x by x plus 7. That gets me a big chunk of the way there. Then all I need is to have an m in front of this x. So to get there, I do a stretch of scale factor 1 over m, because if I want to multiply by m, I need to figure out what to divide by, and that's in the x direction, and that gets me to my answer. In this question, if you've done the stretch first, it actually makes it a bit harder, because imagine you had an m here next to the x. Whatever translation you then do in the x direction, it's going to get times by m, and so it makes it a bit more complicated to figure out what the translation is. If you were to do this as 2 separate translations, it actually doesn't matter where in this order of transformations you do the translation in the y direction. If you want to do the translation of in the x direction of minus 7, that has to come before this stretch because they affect each other. But the translation in the y direction, that can come anywhere because x and y transformations don't affect each other. Let's have a look at part 2. Explain how you can tell f is a 1-1 function. Well, for a 1-1 function, one input will give exactly one output, and each output has exactly one input. The reason I've given for this is not the one in the mark scheme, but it would be valid, is that this function is increasing over the whole domain. It starts here and it goes up all the time, never comes back down. If a function is always increasing or always decreasing, then as long as it's continuous and there's no gaps in it, it will be a 1-1 function. So that will be the answer to part 2. We also need to find an expression for the inverse function. That's relatively straightforward. It's something you've been doing since GCSE. Let y equal your function, do a little bit of rearranging, and you end up with your inverse function. I've added a little extra bit that's in the mark scheme here, that's not in the mark scheme, sorry, here, that does tend to be in the mark scheme on questions in the new spec. When you specify an inverse function, there is sometimes a mark, even if it doesn't ask, for specifying the domain. I've put the domain next to this as x is bigger than or equal to 4. Technically, it is required as well, because if you don't have this domain, this won't be a 1-1 function, which means it can't have an inverse. So how did I know it's x equals minus 4? Well, if I go back to the graph, the range of the original function is x is bigger than or equal to minus 4. And so if the range of the original function, f, is minus 4, then that tells me what the domain of the inverse function is. X is bigger than or equal to minus 4. Okay, part 3 then. It's given the curves y equals f of x and the inverse of x do not meet. Explain how it can be deduced that neither curve meets the line y equals x. What it's looking for here is you to demonstrate knowledge that you know that an inverse function, a function and its inverse are reflections of each other in the line y equals x. And if they are reflections of each other in the line y equals x, then if they do meet, they will meet on the line y equals x. So we'll have a look at what I've written, and then we'll do the next part, determine the set of possible values of m. So I've pretty much written here what I've just said, that the reflections in the line y equals x. In order to solve what the values of m will be, if the two curves never meet, that means if you try to solve the equation f of x equals the inverse of x, you should get no solutions. but it's also helpful to use the fact we know that these curves meet, the solution to this equation is also on the line y equals x, so we can put equals x in here as well. And we can solve any of these equations that we want, or in this case we can attempt to solve any of the equations. We won't get an answer for this question. So in general it's usually easier to use one of the equals x parts, because quite often solving f of x equals f to the minus 1 of x gives you something a bit more complicated. In this particular case I've chosen to solve f to the minus 1 of x equals x. Now it is possible to have used f of x equals x, I just think it would probably have been more complicated. So here I've set I've set the inverse function equal to x, and then I've rearranged that equation as if I was going to solve it. But I'm trying to find the values of m that this is valid for, and I know that there is no solution to this equation because the curves do not meet. So once I've got my equation into quadratic form, if there are no solutions to a quadratic equation, it means the discriminant is less than 0. So I've done b squared minus 4ac is less than 0. That's given me a quadratic inequality, which I've solved, and I get the answer minus 2 is less than x is less than 14. So this was a question at the end of an exam paper. It was expected to be tough, and not that many people will have got full marks for this question. However, I do think there's a lot of things in this question. If you understand this question well, then the vast majority of graph transformation questions and function questions you'll probably find pretty straightforward.